This is Module 4 of Mechanics of Materials Part 2. And the learning outcome for today, last time we looked at the longitudinal stress. This time we're going to develop an expression for what we're going to call the hoop stress for a thin-walled pressure vessel. Again, in terms of the pressure itself and the dimensions of the vessel. So where we left off, again, last time we took an engineering structure. It had external loads applied to it, the pressure inside. And we cut that vessel in the vertical direction, and we found the longitudinal stresses. And that longitudinal stress was found to be P times pressure times the diameter over 4 times the thickness of the wall of the pressure vessel. So now I'm going to, instead of cutting it on a vertical plane, I'm going to cut the vessel on a horizontal plane, and we're going to call those hoop stresses. And so here is a diagram of that cross-section where I have my hoop stresses up acting on the surface of the wall and my pressure acting down. And so here's a blow-up of that same diagram. And so again, we're going to apply the equations of equilibrium. In this case, I'm going to sum forces due to these stresses in the y direction. Set them equal to 0. And so I have my hoop stress up times its area, and in this case I've taken a section cut that I'm calling a distance L long, and so I've got the hoop stress is times on one side it would be the thickness times L, and we have two sides here, so it's going to be 2 times the thickness times L is the overall area that the hoop stress is acting on for this particular cut. And the pressure is down, so that's going to be minus P times the unit area. And in this case, that's L times the diameter of the cross-section. So L times D. And that all equals 0. I can cancel out now again L. And I find that the hoop stress is equal to PD over 2t. And so here's that result. So we've now found both the longitudinal and the hoop stress for a thin-walled pressure vessel. And we'll go ahead and put that together and look at an overall analysis in the next module.